Hi, my name is Mark SEDE and I'll be introducing you to the Spatial Enrichment Data Engine application, or SEDE for short, and the team behind it. So along with me we have Christopher Beatty, Evan Taylor, and Tessa Nishida. And so we are the INL clinic team, and we have been sponsored by Idaho National Laboratory to make a contribution to their All Hazards Analysis Framework, or AHA for short. So AHA is a dynamic dependency analysis framework that is designed for the collection and visualization of critical infrastructure data in the United States. The AHA software identifies dependencies and associated risks of critical infrastructure points, and it gives decision makers and emergency managers a comprehensive overview of the internet-connected systems in our country. Systems that distribute water, power, and much more. So in times of crisis, when these points are disrupted by natural disasters or cyber attacks, or in any case, AHA can be used as a tool for viewing these complex systems, in responding to emergencies, and ultimately in saving lives. So the part that our software plays in all this is that it will provide AHA with accurate and verified geospatial data. So this includes addresses, latitudes and longitudes, elevation, and numerous other location parameters. So we've done this by building a forward and reverse geocoding web application. This is what it looks like. Geocoding is converting an address to a latitude-longitude pair, and reverse geocoding is going from a coordinate pair back to an address. So this software will provide the AHA framework with the most accurate location data. So INL are our customers. We've been working with them closely to build SEDE, and then we will turn over our code to them when we're done. We've built a robust forward and reverse geocoding application with a clean modern user interface, which will actually have a real-world impact for our nation. So now I'm going to turn over to Tessa, and she will give you a demo of our application.
Hi, I'm Tessa, and today I'll be demoing our SEDE application. If you go to sede.site, you'll see our interactive Esri map. You can place pins on the map by enabling pin mode and clicking on a location. This brings up a dialog with the location's address and geospatial data. This is returned from our backend API. You can then choose to save the pin to the map and data table by clicking on Add. Finally, you can use the search bar to add locations by address or by name. This will bring up a panel with multiple results that you can choose to add. Next, I will show you our import feature, which allows users to geocode multiple locations at once. Here I have a CSV file with coordinates for landmarks across the US. I want to reverse geocode this to get address and elevation data. So I will select reverse, and I can also optionally choose to add a color and tag for these landmarks. When I start importing the file, while the file is being processed by our backend, progress updates will appear here. Now I will show you how to edit saved locations. When I click on a saved pin, this dialog will appear, which will allow users to edit the name, tag, and color of a pin. These changes will be reflected on the map and in the data table. Now that the upload is complete, the address and geospatial data for each of the locations is added to the data table, and the pins are added to the map. So you can see here, we have pink pins for all of the landmarks that were added from the CSV file. You can also save the data in the data table to a CSV file by clicking on Export. SEDE also saves your session, so if you close the browser or refresh the page, you can choose to resume your previous session. So here you can see all of the pins and the data table was restored to its previous state. For more information about our app, API, or project, you can click on this help button.
Hi, I'm Evan, and I will be talking about our CI/CD pipeline and deployment. Our project has a pipeline complete with build, test, lint, and deploy stages. This will run every time that new code is committed to our project repository or when a branch is merged into main. Having a pipeline like this makes sure that code is safe, passes our test suite, and is formatted correctly. It also deploys live when our main branch is updated. Each job, like build backend for example, is executed by GitLab runners which live on our AWS instances. We have an Ubuntu instance for front-end jobs and a Windows instance for backend jobs. Our project is also deployed through our Windows AWS instance, and it has a valid certificate and can be found at SEDE.site. Now I'll pass it on to Chris, who will talk about our project's tech stack.
To make our project, we used ASP.NET Core for the backend and Angular for our front end. These were requested by our sponsors, so we made sure to use those. To host, we put our project on AWS. And to document our project, we used Swagger. We used their open API spec file system to generate our endpoints and to keep those documented. We extensively use GitLab's issue tracking system to manage our project. We ended up closing over 140 tickets between the four of us. And we implemented 39 tests on the front end and 80 tests on the back end. And these were all automatically ran in our pipeline every time we deployed a new change. We ended up creating 5 API backend endpoints with Swagger documentation as well. And as we developed our project, we made sure to incorporate ongoing feedback with our sponsors, INL. And this included a lot of minor style adjustments. So for example, we made improvements to our pin dropping features on our web UI. We made sure to get a valid certificate by hosting on a domain. And we made sure to make our widgets consistent in their styling, their requests as well. And then there were also some backend improvements, such as making sure to delete stale requests after API endpoints have served up their data. And just to wrap it up, we ended up making a fully functioning product that does exactly what our sponsors desired. We managed to finish all of our rank 1, 2, and 3 features to create a forward and reverse geocoding API and a front end to make use of the back end as well. We want to thank our sponsors, INL, for taking the time to give us good project requirements, give us feedback, and to give advice on the execution of our project. Thanks for watching.